girls in the classroom to be very interested in science about energy because energy is everywhere. And I'm going to show you a little bit of energy right now.
All right, morning everybody. Hello there. Hi. Hi. So I guess unless it's not morning, like for you it could be afternoon, but it's like a 50-50 shot there, I guess, but most of us are sleeping for most of the morning, so less than a 50-50 shot. I mean, maybe if everybody gets up to 8, you only get like 4 hours of morning, much more of the evening and afternoon, especially you guys. You tend to stay up really late. And
get on with it. Yes, get on with it.
Okay. All right, so here we go. We're going to talk about law of conservation of energy. That's pretty dang exciting. It's really, here's the equation right here. We're saying that the total energy of a system, okay, remains constant. And that is the sum of each of the individual pieces, types, whatevers of energy. Mainly we've talked about potential energy, a form of mechanical energy, kinetic energy, a form of mechanical energy, and we've touched on thermal energy or heat energy, and that's that Q right there. So again, potential energy is stored energy, and we've talked about 2 ways to store energy, at least with some equations and math, and that is gravitational potential energy, so stored in a gravitational field, and spring potential energy, so stored in a squishy spring, okay, or stretchy spring. Don't want to misrepresent springs, okay, and then we have kinetic energy, energy of motion. So we here today are going to be talking about an example problem. All right, so here we go. We have 2 buckets here. This one right here is going to be representing the potential energy, and this one over here is going to represent the kinetic energy. Each one of these balls is representative of, we'll just say like 1 unit of energy. We won't try to like quantify it just yet. This will be totally qualitative so that we can not really worry too much about numbers. So here's the basic idea. Right now, there is no energy in this system. Both of these buckets are empty. Both of these buckets are energy. Anyway, so we have to do work. We have to do work to put energy into this system. So we have my lovely assistant here who's going to help me out. He is going to do work to put energy into that system, meaning he is going to place units of energy, these balls, into the system. So this would be likened to raising this ball up into the air, like so. As we raise it into the air, we are doing work against gravity. We are storing energy in the gravitational field. Okay, so as I raise this ball up, I'm doing work on the system. I'm giving it energy. So 1 unit of energy in, 2 units of energy in, 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10. Okay, so bunch of energy is now in this bucket. 10 units of energy. The ball is way up in the air. This is the highest the ball is going to go because I'm done, my lovely assistant is done working on the system. So what does that mean? That means that all the energy that is in that system is there now. It's not going to get any more. So an external force puts that energy in, and then there it is. Okay? So whatever it has is all that it's going to have. It's all that it can have. So now when I drop this ball, it is going to fall down. So that gravitational potential energy is going to be converted into energy of motion. And as it's converted into energy of motion, it's going to lose some height. Okay? So as it falls, right, that energy is stored in position. Well, that position decreases. So where does that energy go? Well, it's moved over into kinetic, all right? So as we see here, all right, it goes down a little bit, 1 unit of energy over into kinetic. Goes down a little bit more, another unit of energy over into kinetic. And that process continues, right, all the way from the highest point to the lowest point, right? You can see now here, when we get to the bottom, all of that energy is now in the form of kinetic energy. And that's really what this is all about, right? It wasn't potential energy, now it's in kinetic energy. The total energy stayed the same. So we had work done on the system, right? Lovely assistant brought over units of energy, and then it was in potential. We stored it as a unit of position, okay? And then it converted from that position energy to energy of motion. And we were able to then see that, right, as those units of energies move from one bucket to the other bucket. And just as a fun fact, I also have energy, which I'll be converting to kinetic energy right now. Whee! Boom. So, back on the ground now, picking up the ball. No more gravitational potential energy, except I guess I'm doing a little bit of work on the ball right now, picking it back up. Pretty dang exciting. All right, on to the next one. The famous pendulum bowling ball thing of death. No tricks, nothing up my sleeve. Testing to make sure that the rope is securely fastened. Pretty fancy. All right, so I'm doing work right now, pulling it up into the air. I am giving that bowling ball energy. Only so much energy. Only the energy that corresponds to the value of my nose. Then I'm going to let it go, and it's going to swing away from me, and it's going to come back, and it's going to smash me right in the face. Except it can't, because I've given it a particular amount of energy, and it can never have any more energy than that. It'll only ever reach the same height or lower. And in fact, this time you notice that it is significantly lower than my nose because of friction, because of air resistance, because of all the things that actually exist in the real world. And you see, even here, after 2 swings, I catch it significantly lower than my chin. First time, release it from my chin, then it's like mid-chest, and then it's like belly button.
You're still here? It's over. Go home. Go.